So today we're going to start our lesson by looking at this sign and asking what is the meaning of this sign. I've given you guys 4 options: icy road ahead, steep road ahead, curvy road ahead, trucks entering highway ahead. Now, if you pick the following answer, give it a second, it's being a little slow. Steep road ahead is the correct answer. You can pretty much tell by the fact that the truck is at an angle. What if we go ahead now and switch over the sign, but this time we add a percent to it? So 7%. What does a 7% mean on this sign? So the bigger the percent, the more incline the hill is going to have. So in this case specifically, it means the slope of the road. So what angle are we at? So what the 7% really means in terms of feet is that for every 7 feet that we drop vertically, it's going to be 100 feet horizontally. So visually, what that means is for every 7 feet here, there's going to be 100 feet across. So vertical 7 feet, across 100 feet. So the bigger the slope, the bigger the angle. So here's another picture of it. And so what is slope? At the end of the day, it becomes how steep a line is. At what angle? Is it a big angle or is it a small angle? So we're going to get into our actual notes now. So we can see slope in many situations, one of them being like ice skiers have to determine the slope of a mountain before they get on it, because if it's too steep, they can pretty much go too fast and crash, perhaps even die. So they got to be careful with that kind of stuff. So what is the slope? So slope is the rate of change of a line. So how quickly it changes from one piece to the next piece. How fast does it drop? So we've already done this before when we were talking about tables and writing out the graphs. So just as a recap, so we had a table back in August. We would go ahead and figure out the rate of change, so of the output, meaning the y value. So this one is changing by a factor, by a sum of 3. But we have to also check the change in the x values. These are changing by 1. So this is going to be a 3 to 1 change, or a 3 change. And we start at -5. When we wrote our equation, we used our y equals mx plus b, where the rate of change was the m and the start was the b value. So we would write our equation as y equals 3x minus 5, where 3 is a rate of change. So it should be appearing any second now. There it is. So in this case, we have the 3 and the -5 both appearing on our table. Let's do one more example. So here, the rate of change on the output, this time I called it f of x, but it's just your y value. This one is decreasing by 6, and my y values are decreasing by 6. My x values are changing by 3, and they're increasing. So I would have a -6 to 3 rate of change, which is really just a -2. My starting value would be at 14. If I wrote my function, I would get the following function. F of x equals -2x plus 14. Give it a second, there it goes. So again, I simplified the rate of change to -2x plus 14. So this is a quick recap of what we've gone over before, but to bring it back to what we know, this -2 right here represents my rate of change, which is also my slope. How fast is my line going to be dropping in this case, because it's negative. So if you have the equation, you should automatically know the slope as long as it's in this form. So let's go now into our actual notes, which is where you're going to be writing things down. What is slope? It is the rate of change. It's the slope equal to the rise over the run. Or in another way you may see it is with the little triangle y, little triangle with an x. These mean, the little triangles here, mean the word change. So the triangles represent the word change. They're Greek letters. They're deltas, and when we use them in math, we refer to them as the change in something. So the rise over the run would be the change in y over the change in x. So you should be writing this down on your paper now. The triangle with the y, or the change in y, over the change in x. So y goes at the top because we're talking about the rise. Rise is vertical, the y-axis. Run is across, which is across the x-axis. So change in y over the change in x. Then we move on to adding a little bit more things. We're going to go over how to find the slope from 3 different things. The equation, which we just saw on the previous slides, and the table. So we got the slope or the rate of change from the table, and we wrote our equation, and you can get it from the equation. So we already have those 2 done from previous knowledge. We're going to go over today how to get the slope from a graph and from 2 points. So we're going to start with the graph first. So we should be moving to the next page on your handout. So the slope from a graph. So when we have a graph, all we have to do is pretty much just count. So we're going to just count how far it goes up and down and how much it goes left and right from one point to the next. So when we do that, we're going to look at a pre-made graph. This first example is not in your notes, so just as a visual. So in this case, we're going to look at the 2 points given. We're going to look at the rise over the run. So I'm going to see how much does it go up. So we start on the left side. And I'm going to count how many little squares or how many units it goes up and how many units it goes across. So I'm going to go ahead and count. Here it goes up a total of 3 units. And if I count across, it's going to go across a total of 6 units. So that would be my rise over my run. In this case, my rise is 3 and my run is 6. So it's going to be 3 over 6. But with fractions, we always reduce them if we can. We can take these 2 and divide them by 3. So I get 1/2. Always get your fractions in lowest terms. So for this line that you see here, the slope or the rise over the run is 1/2. So this should give you a picture of what your actual notes look like. We're going to be working on this left-hand side, just the graphs. We're going to be looking at the slope from a graph. So let's find the rate of change for all these graphs, or the slope. So let's focus on number 1. We're going to zoom in on it. So here we have number 1. We're going to start on the left side. It's easier to start with the point on the left. So I'm going to check how much I'm rising. So in this case, it's rising a total of how many units? So we just go ahead and count them. Count from 1 to the next, or count the number of boxes or units. We should have a total of 7. If we draw our line across, we should be able to count the units across for my run. That's going to give me a total of 4. So my rise over my run is rise 7, run 4. So my slope should be 7 over 4. I'm going to repeat the process for the next one. You can pause it and do it and then come back and check. So I'm going to go ahead and do number 2 now. So I'm going from left to right. In this case, I would not want to rise to go to the next point. I'm going to go down. So when we say the word rise, we really mean up and down. So we're going to rise 1, but since it's going down, we say it rises -1. So we got to be very careful with those negatives when the line does go down. And then we're going to run across, just count all the boxes across. And that's going to give me a total of 7. So we rise -1 because it's going down, run 7, which means my slope is -1 over 7. And let's go ahead and move on to the third example. So third one, we start on the left side. We're going to rise, this one in the positive direction, a total of 5. And we're going to run just a little bit across. It's just 1 unit, so it's going to run 1 across. So my slope in this case is rise 5, run 1, so 5 over 1, which is going to simplify to just 5. So my slope is 5. We're going to go ahead and move on to the next piece. You don't have this on your handout, this next slide. Just pay attention for this section. What about horizontal lines? They don't go up and they don't go down. So if I take my idea of rise over run, what does that mean exactly? This line doesn't rise. So what that means is if I were to go ahead and pick any 2 points, I'm allowed to pick any 2 points on the picture. Let's say I pick the point here and I pick a point here. So I would not need to rise. I would just go ahead and run. So my rise would be 0. My run would be, in this case, 4. So it would be 0 over 4 here. and 0 over 4 is just 0. So there is no slope in this case. So a line that is horizontal would now have a slope. It's just 0. It doesn't go up, it doesn't go down, it just goes across. The slope is 0. So let's talk about now vertical lines. So let's say we have a vertical line, and I'm going to talk about its rise and its run. So let's say I pick this point right here and a point up here. So this one rises 5 and runs 0. So it rises 5 and runs 0. But oops, we have a problem right here. We are not allowed to divide by 0. So this is going to have no slope. And this we call, it has a special way to name it. We can say it has no slope, but the mathematical term for it is the following. We say the word undefined. It has no definition. We cannot take a number and divide it by 0. There's no definition for this, so we use the word undefined. Vertical lines have no slope. So on your handout now, at the very, very bottom right corner, you should be able to write down the following. Horizontal lines, the slope is 0. Vertical lines are undefined. So go ahead and fill those two little blanks up with the word undefined on the right, 0 on the left. All right, so now that we've gone through that, we're going to go ahead and move on to the next section. So my videos are long, so I'm going to stop it and go ahead and watch the second video now.